Welcome to the DIY Honda Garage channel. The DTC P0A11, also known as the DC-DC converter activation circuit malfunction, is a crucial diagnostic trouble code that indicates an issue with the DC-DC converter in the 2023 Honda CR-V. This error is specifically related to the communication between the powertrain control module, PCM, and the DC-DC converter, which is responsible for converting high voltage from the hybrid battery to a lower voltage to power vehicle accessories. When the PCM does not receive a boost demand notification from the DC-DC converter, it determines there is an abnormality, prompting the storage of the DTC. The PCM plays a central role in monitoring and controlling various vehicle functions, and its failure to accurately receive input from the DC-DC converter can lead to other performance issues. The DC-DC converter is usually located in the vehicle's hybrid system area, often near the battery pack, while the PCM is commonly found in the engine compartment. Understanding this error code is the first step toward diagnosing the underlying problem and ensuring the vehicle operates efficiently. The DTC P0A11-00 entails a malfunction in the DC-DC converter activation circuit, impacting its ability to function correctly. This component plays a vital role in converting high voltage from the vehicle's hybrid battery into a usable lower voltage. The failure of this component can hinder the performance of electrical systems reliant on this lower voltage, as well as the overall efficiency of the hybrid system. Located typically near the vehicle's hybrid battery, the DC-DC converter is crucial for boosting demand notifications sent to the PCM. When the PCM does not receive these notifications, it interprets this as an error, leading to DTC storage. This becomes even more problematic considering the essential functions the PCM fulfills, including power management and diagnostics for numerous vehicle systems. Various issues may lead to the triggering of DTC P0A11-00. One significant potential cause is wiring problems, specifically a short or open circuit in the DC-STS circuit, which can prevent appropriate communication between the DC-DC converter and the PCM. These wiring faults may arise from corrosion, damage, or wear over time, highlighting the importance of a thorough inspection. Another possible cause is the failure of the DC-DC converter itself. If the unit is defective, it cannot send the necessary boost demand notifications to the PCM. Lastly, a malfunctioning PCM may also be at fault, which implies that if both the DC-DC converter and the wiring are intact, the PCM could be the cause of the issue. This requires careful diagnosis, as it is the central computer controlling various aspects of vehicle operations. When DTC P0A11 is active, the driver may experience several noticeable symptoms. First, engine performance issues may occur, including reduced power or irregular operation, which can greatly affect drivability. Additionally, electrical system malfunctions, such as flickering lights or failure of accessory systems, could indicate the DC-DC converter is not supplying adequate voltage. The activation of warning lights on the dashboard is another common symptom associated with this trouble code. These warnings alert the driver to check the hybrid system and can lead to further diagnostic checks attempting to pinpoint the issue. Essentially, these symptoms collectively suggest that an internal malfunction has taken place in communication pathways between the PCM and the DC-DC converter, which necessitates immediate attention. The first step in troubleshooting DTC P0A11-00 involves a test drive of the vehicle, allowing for observation of the engine's behavior under normal driving conditions. Driving the vehicle will enable the technician to assess whether any symptoms associated with the DTC manifest during operation. After driving, Stopping the engine with the auto idle stop feature serves to simulate conditions under which the PCM examines the DC-DC converter's input. This methodology helps ensure that any boost demand notifications generated are effectively communicated to the PCM. By confirming that the PCM is receiving the proper notifications, one can determine if the fault lies within the circuit, the DC-DC converter, or the PCM itself. If any abnormalities are detected during this phase, further diagnostics will be required to isolate the issue. The next troubleshooting step involves a detailed inspection of the DC-STS circuit. First, ensure that the DC-DC converter connector A and the PCM connector A are both disconnected. This condition sets the stage for clear and accurate testing of the circuit without any interference from connected components. During the inspection, look for any signs of open wires or shorts. The expectation is that with ignition in the on position, the DC-STS circuit should read less than 1 ohm of resistance. If there is an open wire or the readings vary excessively from norm, this step indicates a fault in the circuit, necessitating further repair or correction. Conversely, if normal resistance is confirmed, move on to check if the DC-STS is shorted to power, verifying that all wiring is intact and functioning as designed. In this step, the focus shifts to the DC-DC converter itself. Since there's no direct procedure to test this component, the most effective method is to install a known good DC-DC converter to confirm whether the failure can be reproduced. Disconnect the faulty converter and carefully replace it with the functional unit. Once installed, monitor the system for any indications of restoration in performance or resolution of the DTC. If the vehicle operates normally and the DTC clears, it validates that the original DC-DC converter was indeed defective. In contrast, if the failure persists even with the known good converter, the issue may lie within other interrelated components in the circuit, necessitating further diagnostic actions. The final step in diagnosing DTC P0A11-00 is to scrutinize the PCM itself. After the previous inspections have ruled out other components and wiring issues, focus shifts to the configuration and operational integrity of the PCM. Confirm that the other inspection items pointed to a normal condition, which isolates the PCM as the potential source of the error. If all checks reaffirm the PCM's electrical connections are intact and that it's functioning as expected, then it is indicative of having a problematic PCM. A failure here can adversely affect numerous vehicle functions. Thus, confirming this diagnosis leads to the necessity of either repairing or replacing the PCM to restore vehicle functionality. After completing all troubleshooting steps and performing necessary repairs or replacements, it is vital to verify the outcome. Begin by using a diagnostic tool to clear the DTC from the PCM. Following the reset, conduct another test drive to ensure that the vehicle operates without recurrence of symptoms or warning lights. This step confirms that any previous failures tied to the DC-DC converter activation circuit are resolved and allows the technician to assess the effectiveness of the corrective actions taken. Lastly, confirming the vehicle's operational efficacy offers peace of mind that the vehicle is functioning as designed. If the DTC reappears during or after the test drive, further investigation and potential retesting of previous steps may be necessary. Preventive maintenance is crucial for avoiding future occurrences of DTC P0A11-00. Begin with routine inspections of the wiring associated with the DC-DC converter to catch any potential issues early. Regular checks can identify fraying or corrosion that may lead to circuit malfunctions. Additionally, Keeping a close eye on the performance of the DC-DC converter itself ensures that it continually functions within its design parameters. This might involve periodic checks of its connections and operational performance. Furthermore, ensure that the PCM is updated with any manufacturer-recommended software modifications or upgrades, as these updates often fix known bugs and improve overall vehicle performance, mitigating potential issues that could trigger the same DTC in the future. In summary, the diagnosis of DTC P0A11-00 or DC-DC converter activation circuit malfunction requires precise troubleshooting to isolate the issue. A thorough inspection of wiring in both the DC-DC converter and the PCM is essential for identifying the root cause of the error. Understanding how these components interact is vital for effective repairs, as failure in one area can impact the whole system. After repairs have been conducted, verification is crucial to ensure that the system operates correctly post-repair. Regular preventive maintenance plays a significant role in avoiding the onset of such issues in the future, thereby maintaining the long-term reliability of the vehicle. By staying proactive with inspections and updates, vehicle owners can enjoy a seamless and efficient driving experience with their Honda CR-V. Please like and subscribe to the channel. See you next time!